Hi everyone, the topic we are looking at is functions, and we actually did take a look at this back in March, but I know many of you were unable to do the quiz, so we're going to retouch the topic before going on to other things. So a function is a relation such that every member of your first group, your domain, is mapped to one member of your second group or range, and functions carry their own type of notation. So here in the first line, you'd see f, open brackets, x, close brackets. This stands for a function called f, and this is read as f of x. So you'd usually see the letter f representing functions, but you'd see other letters as well, such as g and h. And here we have this notation representing g of x, a function g, and h of x, another function h. There's also another way of representing functions in the second line. You'd see f colon x with an arrow. This represents the same thing as we had in the first line. It is read as f of x. Similarly, this is read as g of x and h of x. So as we do more questions, the notation will become very easy to you all. We're going to look at an example now. Here we have the function f of x equal to 3x plus 5. So the x here in brackets stands for an unknown or a variable. X represents any number that could go into the function of f, and any number that goes into the function follows the process 3x plus 5. Now 3x stands for 3 multiplied by x. So any number that takes the place of x will be multiplied by 3 and then added to 5. We're going to look at a couple examples involving f of x. So in example 1, we are asked to evaluate f of 4. In other words, we are asked to put 4 into the f of x function. So we're going to write back f of x. F of x is equal to 3x plus 5. And we're going to use the process of substitution to determine f of 4. So everywhere we have the letter x, we're going to replace it with the number 4. So f of 4 is equal to 3x, that's 3 by x, so that's 3 by 4 plus 5. So 3 4s are 12. 12 plus 5 is equal to 17. So f of 4 works out to be 17. When 4 was placed in the f of x function, 17 was obtained. Let's look at example 2, where we are asked to evaluate f of negative 1. In other words, we're going to put negative 1 into the f of x function. So writing back f of x, 3x plus 5. Everywhere we have the letter x, we're going to replace it with negative 1. So f of negative 1, it's 3 multiplied by negative 1 plus 5. And 3 multiplied by negative 1 is negative 3. Negative 3 added to 5, positive number is bigger, so you'll get a positive result. You'll get positive 2. So when negative 1 was placed into the f of x function, 2 or positive 2 was the result. Let's look at a third example. Here we're using a different notation, g of x with the arrow. And g of x is equal this time to x squared plus 1. So any value that takes the place of x is squared and then added to the number 1. We asked to evaluate g of negative 5. So g of negative 5 is equal to, and we could write this like how we wrote the function before, x squared plus 1. Now we are about to substitute. Everywhere we have x, we're going to replace it with negative 5. So g of negative 5 is equal to, not x squared anymore, but negative 5 all squared plus 1. Negative 5 by negative 5 works out to be positive 25. So g of negative 5 is equal to 25 added to 1. G of negative 5 is 26.